In this video for positive maths, we're going to learn about the modulus of a complex number. So the modulus of a complex number is denoted by z in between two lines, is the distance from z to the origin. So if z is equal to a plus bi, so any complex number, then the modulus of z is equal to the modulus of a plus bi, which is equal to the square root of a squared plus b squared. So let's understand why this is. So if we take the point a plus bi plotted on the origin diagram, we're looking for the distance between the point and the origin. So that's equal to the square root of a squared plus b squared. Okay, so as I said, we're going to understand why this is. We take this as a triangle. We have a right angle triangle. The distance from the origin to here, that's our a value, that's our real number. The distance from the x-axis up to that point is b. So we know using Pythagoras' theorem that we can find the distance of the hypotenuse by finding the square root of a squared plus b squared. So let's work on finding the modulus for the following examples. So let's have a look at the following examples. We have to find the modulus of minus 1 plus 2i. So just to identify, our a is equal to minus 1 and our b is equal to 2. So that's going to be the square root of minus 1 squared plus 2 squared. So that will be the square root of 1 plus 4, which will give us the square root of 5. Okay, our next example. Here, the real part is equal to 0. So just to include it, that would be 0 squared plus minus 2 squared. So we're just going to get 0 for the first part, and minus 2 squared is going to give us 4. So the square root of 4 is 2. And part 3, in this part we don't have the imaginary part, so it's just going to be the square root of 8 squared, and again, just to include it, for the example, 0 squared. So the square root of 8 will be our answer for the third part. We could also break this down as the square root of 4 by the square root of 2, which will be twice the square root of 2. So for the next activity, we're told that if z1 is equal to minus 3 minus 2i, and z2 is equal to 1 minus 3i, evaluate the following. Okay, so part 1, we have the modulus of z1 minus z2. So that's going to be the modulus of minus 3 minus 2i minus 1 minus 3i. So if we simplify, we have minus 3 minus 2i minus 1 plus 3i. This is going to give us a modulus of minus 4 plus i. So again, it's going to be a squared, so that's minus 4 squared, plus b squared, so that's plus 1 squared. So we're going to have the square root of 16 plus 1, so the square root of 17. So let's have a look at part 2. We're looking for the modulus of z1 multiplied by z2. So z1 is minus 3 minus 2i. z2 is 1 minus 3i. So we're going to multiply out our brackets and then find the modulus. So minus 3 by 1 is going to give us minus 3. Minus 3 by minus 3i is going to give us plus 9i. Minus 2i by 1 is going to give us minus 2i. And minus 2i by minus 3i is going to give us plus 6i squared. What we want to remember at this stage is that whenever we have I squared, we always change it to minus 1. So that's what we're going to do on the next line. So we have minus 3. 9i minus 2i is going to give us plus 7i. And now we're going to have plus 6 multiplied by minus 1. So we're going to have minus 3 plus 7i minus 6. So we will have minus 9 plus 7i. So to find the modulus, that's going to be minus 9 squared plus 7 squared, which will give us the square root of 130. For more videos, visit www.PositiveMaths.ie, email us at info@PositiveMaths.ie, and follow us on Facebook and Twitter. Thanks for watching.